The scores weren't quite sort of what we were expecting. It was quite clear that we had to fix a couple things to improve things down the road.
Everyone who trained a model has war stories. We asked top researchers to share theirs.
So my name is Sam. I'm a postdoc. My background is in neuroscience, and we're currently integrating machine learning into our work.
And I'd love to learn more about your research.
EEG can be used to do downstream clinical tasks such as seizure detection, detecting brain activity abnormalities, and we use natural language to pre-train models and to obtain useful data representations to do those kind of clinical tasks.
And could you recall a model training moment that didn't go as planned?
Initially, we took kind of a standard clip approach, trying to align full EEG recordings in our case and full clinical text reports, but it turned out that there was quite a lot of misalignment there, and so we had to work through some issues to improve sort of for this domain specifically how to do this alignment, which involved in our case sort of cropping and breaking up the time series and the text into different pieces such that the alignment could be done in a bit more of a reasonable and context-dependent manner.
And what was the very first anomaly that told you something was off?
Well, basically that was mainly driven by like downstream performance. The scores weren't quite sort of what we were expecting, given that the text really provides quite a bit of supervisory signal during pre-training, and so it was quite clear that we had to fix a couple things to improve things down the road.
Roughly how much compute or wall clock time did the failure burn, until you caught it?
I would say in our case it was like fairly well and pretty quickly detected, so maybe like a couple days of compute, yeah.
Mm-hmm. What ended up being the key fix for you?
So this was really kind of like a methodological thing and kind of a bit more carefully thinking about what we are trying to do, what are the specifics of the data modality and sort of the particular use case, and sort of how is information distributed in the time series, in the text report, in order to figure out how to do this alignment appropriately.
And is there a particular metric that now you're especially keeping an eye on?
The text might describe like a seizure or so in a time series, but we don't know where in the seizure or where in the time series that seizure occurs. Was sort of the time series sparsely aligned, or did it sort of ignore the local information and align the time series more globally, which is not what we want actually.